This lesson is on angles, similar figures, and similar figure applications. Let's talk about angles first. An angle has two what we call rays in geometry, and they are connected at their endpoints by what we call a vertex. So this is called a ray, and this is called a ray. So angles are all over everything in mathematics, but also in real life. There's an application to dental hygiene because they have to know the angle at which the jaw can open. So that's just one application. There are 4 types of angles that we are going to talk about. The first one is an acute angle. An acute angle is an angle whose measure is between 0 degrees and 90 degrees. This instrument that's in the background is called a protractor. And it measures angles. So, if we want to look at an acute angle, he's cute, he's small. That's what an acute angle is. An obtuse angle is an angle between 90 degrees and 180 degrees. So an example of an angle that is obtuse would be angle ABF. And we do a little angle symbol. An angle that's an example of an acute angle would be angle ABC, because it's less than 90 degrees. B is in the middle because the vertex is always named in the middle of the angle. A right angle is an angle whose measure is 90 degrees. So in this case, it would be angle AB, you guessed it, D. There he is. And last but not least is a straight angle. And a straight angle is an angle whose measure is 180 degrees. So it's just flat. So the angle whose measure is 180 degrees would be angle ABE. So that's the scoop on all the angles. Let's do some examples. All right, here's my little cute protractor. Well, we're going to now state the measure of the angle and classify it. Well, angle ABC, again, the classification of it is acute because it's less than 90 degrees. We did that. And then since it's less than 90 degrees, we're going to read the smaller one off the protractor, so it's approximately 80 degrees. I tried to get it right on the money, but it's never quite there. How about ABD? Let's do that one. Yeah, let's. ABD. Well, that definitely is 90 degrees, and that would be a right angle. Okay, let's do the next one. Yeah, let's. Angle ABF. ABF is obtuse because it is more than 90 but less than 180. And then we're going to read the bigger number on this because it's more than 90. See how the opening is definitely more than 90 degrees. And that's going to be approximately 140 degrees. Now let's take a look at ABE. Well, if we look at that one, that goes straight across just like it did on the last one. And that's called straight. And that's 180 degrees. Now there's a little bonus. Let's do CBD. So let me erase what's on here so that we are not confused with the bonus. I love a bonus. Okay, let's do it in blue. So CBD. That definitely is less than 90 degrees, so it's acute. See how cute he is? And then it goes from 80 here to 90, so that measurement would be 10 degrees. Perfect. Moving on. Now we're going to talk about similar triangles and similar figures, but mostly similar triangles. Two triangles are similar if their corresponding sides are in proportion and the corresponding angles have the same measure. So here is the deal. In proportion means that the fraction between the sides are equal. Side AB corresponds to side DE, so that's my first fraction. Side BC corresponds to EF. And side AC corresponds to DF. So these fractions will all be equal, or we say that they are proportional. Now, the measure of angle A is equal to the measure of angle D. See, these are corresponding angles, so they have equal measure. The measure of angle B is equal to the measure of angle E, and last but not least, the measure of angle C is equal to the measure of angle F. So the corresponding angles are equal, the corresponding sides are in proportion. Let's do the next problem. Find the ratio of the corresponding sides of the given similar triangles. Write the ratio in simplest form. So if we think about it, the 5 is going to correspond to 10, and 4 corresponds to 8. You'll notice that both of these simplify to 1/2. So the ratio would be 1/2, and that's what we would type into our homework on the computer. Now let's do this one. Let's figure out the missing side. If I know these two triangles are similar, which they are, let's figure out the missing side. So 39 corresponds to 13, and n corresponds to 5. Well, we know how to do this. We cross multiply 39 times 5, and we get 195 is equal to 13n. Divide both sides by 13, and we get n is equal to 15. And in this case, they don't say any units. Now, some of you might have said, well, I know 13 times 3 is 39. So you would definitely have to get n by just multiplying 5 times 3. That's fine too, but the proportion way will always work. Now let's do some applications. A flagpole casts a shadow of 31.5 feet. It's the shadow. Flagpole. Okay? Makes a little triangle. Nearby, a 9-foot tree casts a shadow of 7 feet. What is the height of the flagpole? Call that n. And again, we use a proportion. N is to 9 as 31.5 is to 7. So we get 7n is equal to 2283.5. Divide both sides by 7. N is 40.5 feet. So the flagpole is 40.5 feet. To double check that, I'm going to multiply it by 7, And then I'm going to also multiply 9 times 31.5 again, and I'm all set, just to double check myself. Not least, a firefighter needs to estimate the height of a burning building. She estimates the length of her shadow to be 8.5 feet long. And this is the firefighter. And the length of the building's shadow to be 63 feet long. Find the height of the building if the firefighter is 5 2/3 feet tall. Now let's solve. These are both similar triangles. So 5 2/3 over n is equal to 8.5 over 63. So we need to cross multiply, but first I'm going to change each of these guys to improper fractions. So I get 17/3 over n is equal to 17/2 over 63. Multiply both sides. So 63 times 17 over 3 is equal to 17 over 2 times n. Now before I start going, well, I can not go that crazy. So 3 goes into 3 once. 3 goes into 63 21 times. So we get 21 times 17 is equal to 357. But I'm going to leave it as 21 times 17 because you're going to see how incredibly cool this is. I have to clear the fraction, so I have to multiply everything through by 2. So I get 17n. And then I have to divide out my 17s. So when I go to do that, these 17s will just divide out, and I get 2 times 21. So my final answer is 42 feet is equal to n. So to recap, the height of the building is approximately 42 feet. Perfect. Now you can do the lesson associated with this mini lecture. Good luck, take care, go for the math.